Here's a question for you. What do a picnic and a compost pile have in common? Give up? A compost pile is basically a catered picnic for billions of guests. All living organisms need nutrients to move, grow, and reproduce. And the truth is, without proper conditions and the right balance of ingredients, there are consequences for the countless decomposers living inside a compost bin. These decomposers, which include microbes, worms, and other invertebrates, break down organic waste and leave behind dark, rich humus. The process begins when green plants transform solar energy into chemical energy through photosynthesis. Plants contain organic energy and nutrients, which are trapped in their remains when they die. That's good news for decomposers, which come in all shapes and sizes. Decomposers feed by breaking chemical bonds in the dead plant material, releasing energy for their use and recycling nutrients back into the ecosystem. Compost is a series of techniques to manage and accelerate the natural process of decomposition. Like many things in life, the art of composting has truths and consequences.
Help! How do I decide what to put in my compost bin? Call a rocket scientist. Enroll in organic chemistry. Consult your Ouija board. Mix browns and greens.
Hi.
Hi, I'm glad you came.
Thanks. Lisa.
I'm Dan.
Hi, Dan.
I got this compost bin and I don't really know what to do with it.
Uh-huh.
I got this, material together, but I'm not really sure how much to put in.
Okay. Well, we've got a lot of important ingredients here.
Decomposers need many different ingredients to thrive. Carbon and nitrogen are two of the most important. A balanced diet for decomposers comes from mixing roughly equal volumes of carbon-rich materials, which tend to be dry and brown, with nitrogen-rich materials, which tend to be green and juicy. Most organic materials contain carbon and nitrogen in varying proportions. Straw is high in carbon, containing about 100 parts of carbon for every part of nitrogen by weight. Grass contains more nitrogen and proportionally less carbon, 15 parts of carbon to 1 part of nitrogen. Most dry leaves have a carbon to nitrogen ratio of about 50 to 1. Food scraps vary widely, but average about 20 to 1. To make hot compost, you need to provide a mixture of high carbon and high nitrogen materials so that the final ratio is about 30 parts of carbon for each part of nitrogen by weight.
What they do is they use the carbon layer as energy, similar to how we use carbohydrates.
Oh.
And then the nitrogen layer they use for growth and reproduction.
Oh.
So with both of those in there and the oxygen and water, it's a party in your bin.
Great, okay.
Water is another crucial ingredient for the compost bin. Water provides the medium for biochemical reactions, transports nutrients, and allows microorganisms to move about in the bin. When a compost pile is established, naturally occurring spores and dormant microorganisms turn active, and the pile undergoes a population explosion of amazing proportions. Bacteria are the workhorses of the process. They live by the billions in a thin film of water that surrounds moist organic material. The first bacteria to dominate the bin specialize in digesting simple sugars and starches, while successive populations carry out the breakdown of proteins, fats, and complex carbohydrates. Gradually, the compost community diversifies. A myriad of different decomposers colonize the pile, breaking down more resistant materials like cellulose and lignin. These decomposer organisms include fungi, actinomycetes, protozoa, nematodes, sow-bugs, mites, springtails, pseudoscorpions, millipedes, centipedes, and earthworms. Waste heat from the metabolic activity of bacteria has a striking influence on the temperature profile of the compost pile. At the outset, the bin typically has a moderate temperature or mesophilic phase, which lasts for several days. The temperature of the bin rises along with the explosive increase in the number of bacteria. The size and composition of the compost determine how hot the pile becomes and how long the high temperature or thermophilic lasts. Eventually, bacteria decompose the bulk of readily available carbon, and the number of bacteria and the bin temperature decline. During the final several-month-long mesophilic or curing phase, the compost matures as a diverse variety of decomposers complete the process.